So we are using the regression line or the equation to predict the final score given the midterm scores. But we need to have this distribution of data to do that. So we put our x, or we let our x to be the midterm and y to be the final. Then again, just like we did in the correlation, we get the totals down here, the summation for x, summation for y. Again, we get the values of x squared, we get their totals here. And then xy, again, we get the totals. So we've said that this is dependent on the formula. Our formula requires that for b, we have n summation of xy minus summation of x summation of y divided by n summation of x squared minus summation of x, then the whole of it squared. So if you check this formula here, you compare this with the formula for the correlation up here. You can see the numerator is the same. The numerator is the same. But when it comes to the denominator, for correlation, we have the square root here. And then we have the values of x squared, and then the values of y, and the y squared. But when it comes to the one for the b, we do not have the square root sign, it's not here. And then we do not have the values for y and y squared, they are not here. Then of course I've said for you to get a, you need to first get b, because you're going to apply the value of b so that you can get the value of a. And so once you do that, once you come up with such a table, then you can now substitute the values. Again, we have 10 students or 10 subjects or people, then that means our n is equals to 10. Then 10 multiplied by the summation of x, y. So xy is x times y. Then once you multiply them, then you add them down here. Then summation of x, summation of y separately, then you multiply them. Then down here again, 10 times summation of x squared, then summation of x, then you square it. Then again, you get 0.5127. So that is the value of b. B is 0.5127. Then when it comes to a, we are saying we have summation of y. So 810 is the, again, you are going to confirm whether that is correct. 810 is the summation of y minus summation of x multiplied by b, or b times summation of x. So 785 summation of x, then this is the value of b, then divided by all that by 10. And you get 40 point, you get a is equals to 40.7531. But remember, our interest is to get this regression line or regression equation given by y is equals to, so you now substitute a, you substitute its value 40.7531 plus b, again its value, then x. So this now forms our regression equation. Y is equals to 40 plus 0.5, then x. So using now this equation, you can easily predict or estimate or even project what will be the values of y given some values of x. So for example, if the midterm score is 50, for midterm score of 50, the projected final score is, so this midterm score is our x. And so where in this equation now, where you have x, you put 50. and then you do the calculations. So you equate y is equals to 66.3881. So this is just but an estimation, but we are saying it is a good estimation. For someone who scored 50 in the midterm, then this equation is telling us that they can score, or they will score, they scored 66.3881. Now, for someone who scores 70, again, for someone who scores 70 in the midterm, then you can see they are scoring 76.6421. So you only substitute the value here. But we're also saying that you can work backward. You can say if, say, for example, the value of, you're given the value of y, you're told that y is actually equals to, so for any value that is not here, say a value like 65. So if you're given that y is equals to 65, that is the final score, is 65. Then using that, you can be able, using this equation, you can be able to get what is the value of x. So you just need to equate that. You need to equate. So now you are saying 65 is equals to all these. Then you make x the subject of the formula. And you solve and get what is x. So and that is it. That is it for this part, the correlation. So today we are only looking at the scatter plot, the correlation, and regression. So those are the three things that that we focused on. And you've seen, we've only considered two types of correlation. That is the Pearson's product moment and the Spearman rank correlation coefficient. And then possibly you can try again with this data here, with this data, you can try to use the Spearman rank. Try to use the Spearman rank and see whether the two formulas will still give you the same answer, will still give you the same correlation coefficient. So you use the on the same data, on this data, you apply both the Pearson product moment and the Spearman rank, and see whether you're going to get the same value for the correlation. So the two different formulas, and see whether you get the same answer. Then you interpret that, then use now regression to be able to predict one value given the other. And the formulas again are straightforward. Then you, with the example we've seen, you can easily do this. Again, this is something you did way back in high school, only that for some of these you only did plotting. Once you plot, then you use two coordinates and you get what is your gradient, what is your y-intercept. But here we are saying that we need to follow this for this specific area in statistics. We need to use a formula for that. So any question? Any question up to that point? So this is what we are going to do. We are going to have an assignment, but you see, well, if I give an assignment with the same values and the same figures, some of you might just copy from each other. So to avoid that, we are going to generate some random values for this. So let me just demonstrate this because we can do this over the Excel. We can do this over Excel. So we have, let me share this. So this is Excel, Microsoft Excel. I hope you can see this.
Yes.
Okay. So we are saying here, you have X and you have Y. So we want to generate values for X and values for Y. So in Excel, we use formulas. And I told you that it is important for you to get to know some of these because even as you visit those offices, you find that they are always using Excel to do some office work, to do some calculations. Rarely will you find those offices, people holding their calculators, doing some maths. So for the profits of the day, you can easily use Excel to get to know what the profits your company has made over the day. And other things, you can easily do them over Excel without having to do them manually. And for some advanced Excel, which again, we are not going to learn in this, but if you're interested, there are avenues for you to get to learn some of these advanced ways of doing things over Excel. There is a way you can set Excel, you just feed some data on daily basis, then at the end of the day, it calculates for you either the profit or the loss you've made, and so on. So for today, we only interested with the demonstrating this, and I want you to generate random variables for X and for Y. So we use a formula. So we say equals. So we first type equals. Then with your caps lock on, you type land between. So you can see if you can be able to read that statement there, run between. So we are saying it returns a random variable between the values you specify. So these are formula that you are using. So you type equals run between, you open one bracket. So once you open one bracket, you can see it is telling you bottom and top. So the first value, the least value, then top be the highest value. So say, for example, between 35, then you put comma and you say 90. You say 90. Then you close that bracket. Then you enter. So you can see it has given you a value. Like mine here has given me 55. It is random. It is any value between 35 and 90. So not all of you will get 55 or any value similar to your neighbor or to your friend or colleague. So once you do that, you can see where my cursor is. You click at that point, then you hold and drag it down. You drag it down all the way up to, say, up to 30. Then once you release it, you can see we have so many values generated. And the values are between 35 and 90. You have so many of them. You see, you have 88, you have 78, you have 42, 35, and so forth. So once you do that, then I want you to come to this, you click on this, then you highlight it. Highlight your values. You highlight, I've not started with the first. So you highlight your values, then you right click and copy. Once you copy, you can come to another cell or column. Again, on that cell, you right click, then paste. So we have options here for pasting. So you paste only the values. That is, you check where you have 1, 2, 3. Then you enter. Now you can see the values now I have here, 82, is different from the first value I have here, 65. The reason for that is because anytime you enter any value, say if I enter any value or anything in any cell, then I click enter, you can see the values are changing. Check here, this is 76. If I write anything here and I enter, you see the values will just change. But these values here are not changing. They are not changing. So for you to be able to work with this, it means that once you create this first one, you copy those values without, you just copy them as values without the formula. There is no formula in this. You can see up here, there's no formula, but once I click here, you can see there is a formula here. Okay, so you do the same for y. So y, let's say y is equals to, again, run between. So for this one, we can say possibly 45, comma, then say 150. 150. Then you enter. So you can see we have generated one variable there, one value there, y. Then you highlight, you drag this with the plus sign again up to 30. So you can see again we have generated some random values. Then you come back here, you click and highlight all of this. Right click, and for those of you who know the sort, you can use shortcuts for this. Then come to this, right click, then paste. So you can see here the first value is 46, but now it has changed to 91. If I click enter, not that one. So if I write any value here or anything outside the column, so the ones which have the formula, they'll keep changing. Anytime I click anything, even anything, they'll keep changing, but these ones won't change. Then so now you can do away with this. You can select all of them, and then you just do away with them. You do away with this. So now you have x and y values, x and y values. So then from here, you can now get your x squared. You can get your x squared, you can get your y squared, you can get your xy. Okay, so again, this is why I want you to, you can just use your calculator to get 82 squared. You get what that value is. 46 squared, you get what that value is. So these are my values. Your values will be different because they will be random. They are going to be different. So then down here, you can get now your sum. You sum them here. Okay. So you can do this over Excel. You can do this over the Word document. You can do this handwritten. Okay. So whichever you find easier for you. Then once you do that, so now you can now get once you have generated this, you can now get a scatter plot. You can draw a scatter plot using Excel. If you are not able to do that using Excel, of which it's good that you learn how to do that using Excel. So possibly later I'm going to share possibly a video that will show you how you can draw a scatter plot. But in the meantime, try to find out how. If not so, just do it on paper, on graph, on paper to scale, and you draw that. Then you again get come back here and calculate all the values. You start with the, again, now come back here. So you say the first thing to do is a scatter plot, and you observe and be able to tell whether there is any direction to show any correlation. Then you also calculate the Pearson's product moment. So you just use the formula. For this, at this point, you can first skip this. You can first skip this for this one. Then you come and do the regression. You find the value of B and the value of A, and then you put that into the kind of equation we have here. So you're going to do that. So that is the assignment for today's class. And so with that, I think we are good.